Hey Tube, welcome back. Have you ever wondered what happens when a server goes down or critical system crashes? How do applications stay online and ensure users don't face any disruption? The answer lies in a powerful system design concept called the failover mechanisms. Today we are diving deep into how failover works and why it's essential for building reliable systems. As always, let's try to answer the question of what. What is a failover mechanism? At its core, a failover mechanism is a backup strategy. It automatically redirects traffic or services from a failed primary system to a backup system, ensuring uninterrupted operation. Think of it as having a spare tire for your car. It's there to keep you moving when things go wrong. Failover is crucial for systems where downtime can lead to like a severe consequences, like things of like think like banking systems, e-commerce platforms, or healthcare applications. Okay, let's try to answer the other question which is how does it work? Okay, it works in four steps. We can think about them. The first one will be monitoring. The system constantly monitors the primary server or resources for any signs of failure. The second thing, which is failure detection. If the primary system becomes unavailable, let's make this quite smaller so it will be easier for us to read. So, if the primary system becomes unavailable, the monitoring system detects the issue. And three, that switch over. The system immediately redirects traffic or tasks to the backup server or the resources. And lastly, recover. So the failed system is repaired and eventually brought back online as the new backup. So this seamless transitions ensure minimal disruption for users. Okay, let's take an example here. We have our system here and we have only one database and we want to add a redundancy to our system, so we add another database server. Okay, so we have monitoring systems that will monitor the health of our database, and our monitoring system detects that our database is failed, the database is not working for a period of time. So the failover mechanism will redirect the traffic or any read and write requests that are coming from the servers to our primary or secondary database. So we have one primary and one secondary. And when it happens like that, we make sure that the system is highly available and it works with no disruptions at all. But this is not the only way that failover mechanisms works. There is multiple ways. There is multiple we can think about multiple types. There is what we call an active passive failover, which is the primary system is active while the backup system, for example, we have this backup system is on standby. Example for that, like a database that activates only when the primary fails, as this example. There is other example which is active failover, like both systems are actively sharing data and actively load and actively like handle read and write requests. Of course, the data need to be replicated between both servers, but we call this active failover. There is also a geographical failover, like traffic switches to a backup system in different locations during a disaster. So, for example, if data center in Europe failing over to like one in North America or something like that, or something like that. Okay, so we have an example. So we can talk about some real world examples. Okay, some real world examples. Netflix uses failover to ensure seamless streaming even if one data center goes offline. Amazon relies on failover to maintain uptime for its e-commerce platform during peak traffic. Banks use failover for transaction processing to ensure ATMs and online banking stay functional 24/7. Okay, there's something important to talk about, which is challenges and considerations when it comes to failover mechanisms. And let me let me make this one like that. There is three things we need to worry about. The first thing is the detection delays, like slow failure detection can increase downtime. The second challenge is the data consistency, because ensuring data is up to date on the backup systems can be quite tricky. Third, costs, because maintaining backup systems can be quite expensive, particularly in active setup. There are best practices we need to follow when it comes to implementing failover mechanisms, and maybe it comes to four things we can think about them that comes to my mind. And the one thing is to regularly test your failover system to ensure it works when needed. The second, use monitoring tools to detect failure quickly. Third, implement redundancy in critical systems to avoid single point of failure. Fourth, use geographical distributed backups for disaster recovery. So, we need to go to our conclusion and wrap up. So, failover mechanisms are the unsung heroes of modern system. They ensure reliability, minimize downtime, and keep users happy even during unexpected failures. When whether you are a developer or an architect or just someone interested in technologies, or a senior software engineer who's preparing for his or her system design interviews, understanding failover is key to building resilient systems. If you found this video helpful, don't forget to like and subscribe and hit the notification bell so you never miss any video, and see you in future videos.